So now let's look and find the exact trig values applying the sine, cosine, and tangent ratios to our first quadrant angles. So let's recall a couple of things here. You probably first started off learning about sine, cosine, and tangent through SOHCAHTOA and applying opposite, adjacent, and hypotenuse sides. And then probably when you were in pre-calculus, you saw that the relationship as we started to graph these angles on the coordinate plane is that sine of whatever angle we'll call theta was always equal to the y value divided by the radius of the angle. The cosine of theta was equal to the x value divided by the radius, and the tangent of theta was equal to the y value over the x value. So let's go ahead and take a look at three relationships here. We're going to take a look at what happens at pi over 6, which again, if you need to think of it in terms of degrees for now, pi over 6 being 30 degrees. We'll look at pi over 4, which would be our 45-degree angle, and we'll look at pi over 3, which is 60 degrees. So the first one that we're going to look at is we're going to take a look at pi over 6. And so what I'm going to do is I'm going to graph my first quadrant angle and say, okay, pi over 6 is going to look something like this. And there's my pi over 6 angle right here at the origin, because remember when I do an angle, I use the positive x-axis and then I rotate it counterclockwise, and so I get pi over 6. That means this right here is my right angle, and then I have a pi over 3 angle here. And so if I apply those special right triangle ratios from earlier, I know this is 1, this is the square root of 3, and this is 2. And from here I can say, okay, the sine of pi over 6 is equal to y over r, which is going to be 1 over 2, or 1/2. I can say the cosine of pi over 6 is equal to x over r, which is going to be the square root of 3 over 2. And the tangent of pi over 6, which is y over x, is 1 over the square root of 3. And it's not important for my class that students rationalize or get the radical out of the denominator. However, some teachers do prefer it. Just remember, if you need to get rid of this square root of 3 in the denominator, you would multiply it by the square root of 3 over the square root of 3, and that gives you the square root of 3 over 3. Either one of those values would be acceptable for me, though, if we talked about the tangent of pi over 6. All right, now let's take a look at what happens when we look at pi over 4. And so again, we'll graph this first quadrant angle. It looks like this now with pi over 4. We'll apply our special right triangle ratios, which are 1, 1, and the square root of 2. And now we'll go and figure out what is the sine of pi over 4. Well, y over r is 1 over root 2. And again, if you need to get the radical out of the denominator, it simplifies down to be the square root of 2 over 2. The cosine of pi over 4 is equal to the x value over the radius, which again is 1 over the square root of 2, or root 2 over 2. And the tangent of pi over 4 is equal to the y value 1 over the x value 1, and 1 over 1 is simply 1. So there's the three trig values, sine, cosine, and tangent for pi over 4. And now the last one that we want to take a look at is the angle pi over 3. And it's going to be the same triangle here as we did with pi over 6, except now it's going to be that the larger of the two angles, the pi over 3 angle, is going to be the one centered, or the one based off of the origin. So there's my pi over 3 angle. And what it means is that the 1 and the square root of 3 are going to change places here. But it is the same triangle. And now I can go find the sine, cosine, and tangent of pi over 3. So the sine of pi over 3 is equal to y over r, which is the square root of 3 over 2. The cosine of pi over 3 is equal to x over r, which is 1 over 2, and the tangent of pi over 3 is equal to y over x, square root of 3 over 1, which is just the square root of 3. So there are the sine, cosine, and tangent values of our first quadrant angles, pi over 6, pi over 4, and pi over 3. And it's going to be very important either to memorize these values or to be able to at least kind of do a quick maybe mental sketch of these special right triangles, because there's going to be a lot of times in calculus where we need to know these specific values, and we really don't want to have to draw a triangle every single time that we want to know what's the cosine of pi over 3. It's going to be really helpful if we just know that the cosine of pi over 3 moving forward is equal to 1/2. So however it is that you learn these values, it's going to be really important that you be able to use them and apply them very quickly when working in calculus.